Now let's go over the pushHead1 function. On the left side is the code for the function, and on the right side is our main. Now the pushHead function is different from the pushHead function in that in the pushHead function we use a double pointer to hold the address of this head pointer, the single head pointer in main. And in doing so, we were able to use this address to modify and add nodes to our list. Our pushHead1 function is a little different in that we're not using a double pointer, but instead we are using a pointer node data type so that we are able to return an address and set head to that address in our main function. Let me go over the logic behind this code and let's just trace it. So first let's go to main. So we go to main and then here we create a head node, but once we get to main we create an activation record in the stack. And inside of main we have our head node. And currently that is pointing to null. So let's comment these two out. I'm just going to go over one node at a time so that I can explain the logic a little bit better. We call our pushHead function, which we set or assign to head. Activation record is created for our pushHead1 function. We go to the function, and in the function we have a head variable in our parameter. In lines 80 we have a new node pointer variable, and then we use the malloc function to create a node inside of our heap. So this new node is now holding the address of 0x100. And then we do our memory check, 81 to 85, and we go to 86. In 86, what we're going to do is we're going to assign data, and we're going to assign it into our node's data. So in this case, we're assigning 15. And then our new node next is going to be null. And then the compiler goes to line 89 and checks if our list is empty. How do we know if our list is empty? Well, if our head is null, if you look at our head, it is null. If this is the case, then we're going to assign new node to head. So we're going to just point head to new node. Head holds the address of 0x100. Lines 95 through 99 is skipped because it doesn't fit the condition. And then we go to one-on-one and it says return head. When we return head, we're actually returning this head in the pushHead function. We're actually returning the address. We execute the pushHead1 function. This is popped off. But this address, this node that we created in the heap, it doesn't get popped off. So now here where it says head, pushHead head 15, we're actually returning. So that's basically saying that saying head equals, but instead of saying head push 15, we're actually returning the address, which is 0x100. And then once we print our list, the output is going to be 15. And our function is popped off. We go through our second function, and in our second function, we create an activation record for pushHead1. And again, pushHead1 has the same data types. We have a head pointer, and we have a new node pointer. And currently, since we return the address here, our head now holds the address of 0x100. We call pushHead1 for the second time. We go through our codes in lines 80 all the way to 87, and this is just creating a node. A new node is created, and so now our new node is pointing to that, and our new node holds the address of 0x200. And if you look at this parameter on line 78 where it says head, we are passing the address of our actual head, which is this. So let's just say that this has an address of 0x50. Right now, this is holding the address of 050. Once we create our new node in the heap, we enter our data, which is 25. And on line 87, this is currently pointing to null. And so now we check our conditions. So we go to line 81, is our list empty? Well, the way we check that is, does our head equal null? Well, if you look at our head, it doesn't equal null. It's pointing to the first node of our list. Okay, well, if that's the case, we want to make the new node's next point to head, or we want to assign head to that new node's next. Our head is pointing to this node, so that's currently our head node. This next is going to hold the value of 0x100. Then we move our head node to point to the first link, or to the first node of our list, because now we have two nodes, and our head node is still pointing to the previous first node, which is now our second node. We move this head node to the new node, or point it to the new node, or assign new node to it. So now our head node is pointing to our new node, and it is now holding the address of 0x200. And so now we return this address to our original head. So head is basically, when we return head on line 101, we are basically returning the address of 0x200. And so now this holds 0x200. This gets popped off, and our head, this head, is holding the address of our first node. And so now when we go to our print list function, the output is going to be 25 and then 15. So now let's go through the same process again. Let me uncomment this. We call our pushHead function for the third time. So we create an activation record for pushHead1, and we have the same variables. So we have a head pointer, and right now that head pointer is holding 0x50. We have a new node in lines 80. We malloc a node in our heaps, and our new node is pointing to that, and our new node holds the address 0x300. And then on lines 86, we assign data to it. And in this case, our data is going to be 40. And then this part right now is just null. And then we check our conditions. Is our list empty? No, because our head is currently pointing to that right now. So therefore, we go to lines 94, where we have one or more nodes on our list. And so we go to the else. And then in line 97, we set the next portion of our new node and set it to head, or assign head to it. This holds the address of 0x200. Then we go to line 98, and remember, our head node should always be pointing to the first node in our list. And currently our head node is pointing to the second node, which used to be the first node. And so now we're going to assign new node to head. So head will hold the address of the new node and point to the first node in the list. So now head is holding the address 0x300. So finally, we return head. Well, what is our head holding? What address is our head holding? Our head is holding 0x300. So this is the same thing as this. And then we complete our pushHead function. This head is now holding the address of 0x300. And so now we are done with the pushHead function, or we've completed the pushHead function. And so we pop it out our list. So then we go to our print list function, and the output will be 40, 25, and 15, because we are pushing our newly created node to the beginning of the list. As far as time complexity, we do not have any while loops or for loops. Whenever we add a new node, we do not have to traverse our elements on our list. We're always adding to the beginning, and it's constant. So our time complexity is O of, or constant, big O of 1. And then our main gets popped off once the compiler returns 0. So I hope that you understood the logic of this function and how it's different from our first function.